Hello students, I am Dr. Rajaram Dhok from Savitribai Phule Pune University affiliated Agricultural Development Trust Shardabai Pawar Mahila College Sharda Nagar Baramati. Let's start. Chemistry of F block element lecture 7 IUPAC Nomenclature System for super heavy element. So in this lecture we see how we give the nomenclatures for the super heavy elements, and for that nomenclature IUPAC system is used. So super heavy element means the elements which have atomic number more than 100. So such type of elements have given the name by using the IUPAC nomenclature to avoid the confusion between the names. So in this nomenclature we see the nomenclature system for that super heavy elements. So that IUPAC have given certain principles for deriving the names to that super heavy elements. So what are that principles? So in that there are certain principles are used. So names of that elements should be short, it should be systematic, and that name should be obviously related to the atomic number of that element. So such type of principles are given by the IUPAC committee. Then names of that super heavy element should be end in IUM, irrespective of the elements, that is the metal. But generally these all the super heavy elements are generally metal, and metal name end by IUM according to this IUPAC system. Then symbol should consist of 3 letters to avoid the duplication of that some symbols which is already given to the other elements, because for 2 digits elements already symbols are given. And so to avoid that confusion, here above the 100 there are three digits, and so here when we use the names then 3 letters are used. Then such type of letters should be derived directly from the atomic number, and that should be virtually related to the names as far as possible. So when we give the names, then such digits, such symbols that can be taken from that letter, and that letters are related to the atomic numbers. So such system for unknown element does not deny the right of the discoverer of new elements to propose other names to IUPAC after the discovery of new elements has been established beyond the doubt in the scientific community. So to avoid the doubts or to maintain the right of that discoverer, that IUPAC has not any oppose, or they have not any objection to give the names. Now we see the IUPAC nomenclature rules. So in that IUPAC nomenclature rules, that committee have given these certain rules, in that the names are derived directly from the atomic number of that element, and that elements which have given the number, and for that purpose that elements roots or numerical roots are used, and for the 3 letter 3 digits roots are used. So here we see that what are the roots for that different letters. So there is, for 0 we use the numerical roots nil, for 1 un root is used, then for the 2 by, for 3 try, for 4 quad, for 5 paint, for 6 hex, for 7 sept, sept sept, for 8 oct, and for 9 in, ENN. So these numerical roots are used. The roots are put together in the order of digits which make up the atomic number, and they are terminated by IUM to spell out the name. So when we give the names, then that every roots mix with each other, and lastly that name is terminated by IUM. In some roots, the final N of EN, so in the EN root, or in there is finally N. So this N is left out when it occurs before nil. Means before nil, if there is ENN, then one of the N is left out and we return the nil. Then one other example, that is when there is finally I in their root. For example, in case of the by, try, then such type of I, and after that there is IUM, then one of the I is left out or that is removed. So such type of rules are used when in certain cases that there is repetition of N, repetition of I, at that time one is removed. Then symbols for the elements, how it is prepared. So for the preparation of symbol, they are prepared by using the first letter from the roots. So from the every roots, first letter is used, and by mixing the three first letters of that root, that symbol is prepared. In that symbol, first letter is written common capital and others are second letter. So this mixture of Greek and Latin roots are chosen to avoid the doubts. So in this way, by using these rules, we can give the IUPAC names. So this method is very simple method. So we see how we can give the names for particular number. So here I have a given table, and in that we see how we give the numbers. So atomic number 101. So in 101, root for 1 is un, root for 0 is nil, and root for 1 is un. So we write un dash nil un and end by IUM. So name is unnil unium. So in between the every root, we put the dash for the identification that for which letter what is the root. So in this way, we give the names. Now, how symbol is used? So every root's first letter, that is UNU. So we write UNU. In that, first letter written capital and others are the second letter. So in this way, for all the numbers which is discovered and which will be discovered afterwards, in that nomenclature system is same. So we see for the atomic number 103, name is unnil biome and symbol is UNB. For atomic number 103, unnil triome and symbol UNT. 104, unnil quadium and symbol UNQ. 105, unnil pentium and symbol is UNP. For 106, unnil hexium and symbol is UNH. So in this way, for all the numbers, we give the number. We see some other names. We not see this all the table because you can understand these by taking certain examples. So we say that atomic number 140. So here 140. So simply we write their roots and end by IUM. So here un for 4 quad unquad nilium and symbol is UQN. We see the atomic number 679, Higgs shaped inium, HSE. Then atomic number 999. Then its name is in inium and symbol is EEE. So in this way, we can apply this IUPAC nomenclature system for these super heavy elements. Now, in this table, some IUPAC names and its half-life period is given. So here for atomic number 104, that is the UNQ 259. Its half-life period is 3 seconds. And for UNQ 261, half-life period is 65 seconds. Which is in some other example 106 unnil hexagon. And symbol UNH 260 isotopes, its half-life period is 180 seconds. And for UNH 263, half-life period is 0.9 seconds. Means from this we can see that here half-life period of these elements are very small, that is in second or also fraction of second. We take the atomic number 108, that is UNO 265. This element have half-life period 2 into 10 raised to minus 6 or 263 seconds. Now here 2 into 10 raised to minus 6 means it is very less than this 1 second. And so discovery of such elements is very difficult. Research of that element is very difficult. And that is the very problems in the study of different properties of that element. Now, in case of the super heavy element, their half-life periods are very less, and some super heavy element shows typical properties. So what is that properties or some observations that elements with even number of proton in the nucleus, means in that atomic number is even, then in that these compounds are generally more stable than the other elements which is neighboring to that element, and that is generally odd number. So simply you remember that the even number of atomic number or proton containing nucleus, they are more stable compounds than the other elements which is odd. And this observation is noted by the scientist Harkin. So this is called as Harkin rule. So this Harkin rule states that elements with an even atomic number are more abundant than their neighbors with odd atomic number. So there are some nucleus. So we say that there are some nucleus which have a proton number 2, 8, 20, 28, 50, 82, 114, 126, 164, 184. These elements are more stable because it contains even number of proton or neutron. And so these elements are called as, or these numbers are called as magic numbers. For that purpose, we take one example, PB 82208. It is very stable with 82 proton and 126 neutron. So such type of observations is also observed in other elements which have even number of protons and neutrons.